I don't have a question, I have a disclaimer. I'm not a runner. I only use Apple Watch. And I'm going to talk about the study we did at Science with Evgeny, myself, and Fotis. Evgeny is a runner, though, the first author, where we evaluated heart rate efficiency for amateur runners. So that's for those who run, that's a kind of typical familiar picture. So runners tend to track everything: pace, heart rate, sleep, recovery. But there is one problem. These numbers that most wearables show are often confusing, inconsistent, and sometimes hard to connect to real progress. So we're asking a question: what if we had one simple, transparent metric that actually makes sense over time? And in the literature of running, heart rate and pace are two most common metrics that are usually interpreted in isolation. I see some nodding from some potential runners. So, but both are highly volatile and they change with stress, caffeine, weather, or the terrain. And taken alone, they don't really tell anything to runners and they don't tell the whole story of real progress. And more worryingly, there are so many commercial platforms out there. You can see some quite popular wearables, Garmin and Polar, the likes. And these wearables try to simplify things with black box scores. So they just produce one score. They tell you that's your heart rate variability, that's your heart rate or pace, or others provide metrics like training readiness or body battery. I'm sure you've seen different of these kind of metrics, but they rarely explain how these metrics are calculated. Most of the times are behind proprietary algorithms and black box scores. And this makes it really hard to trust and even harder to learn what these metrics mean. And that's what we did. We tried to revisit a very simple idea. And this is a metric called heart rate efficiency. And as you can see from the equation there, is just the product of heart rate, pace, and basically it tells you is the number of heartbeats you spend to cover 1 kilometer. And it combines both of these metrics that are often taken in isolation. And it's easy to calculate, easy to explain, and in a sense, we speculate that this could be a better metric for runners. But of course, now you might ask why let not focus only on heart rate and pace and not other metrics like heart rate variability or VO2 max. And there is plenty of these metrics in the literature. And here's a couple of reasons. So we chose heart rate and pace because they're simple, available on any wearable, they're easy and easy to interpret. But metrics like heart rate variability are more about stress than the running process itself. While the VO2 max or lactate threshold require lab tests. But of course, proprietary scores, all these proprietary scores are kind of black box. And another reason is that the HR gives us a transparent and more practical metric for everyday runners. Now, going back to where I started, that the first author was a runner for many years. We started from his own data. So Evgeny kept track of 14 years of running, more than 4,000 runs, where he kept logs of heart rate, pace, distance, elevation. He ran different types of events from marathon to triathlon. Cannot even do that stuff. But also that's the first author. But also we went one step further to collect more data set to see if we can observe some of these patterns. Then we augmented this data set with another set of 12 runners where we get the anonymized logs of these people from a community called Running Ahead. So all this information is publicly available. And we had a third data set where we looked at marathon case studies where we had 16 events for recreational and semi-pro running that were collected from Strava, from the marathon in Cyprus, in Larnaca. One thing I want to stress here, working with this kind of data, one might wonder there is all sorts of ethical concerns. So all these kind of data that we curated in our database, everything was publicly available, all the individuals were connected, consented, but also all the data were anonymized using pseudo-anonymized URLs and IDs without pinpointing back to the users. To analyze this data, I think here there is a little video, if I can play a bit. There is this tool that was developed by Evgeny, and then basically is trying to bring back to the running community a tool that anyone can load their data from any wearable, can plug it in this tool, and then they can understand these metrics that we're discussing today, the HRE. And basically here, as you can see, it's a free client application that runs browser. And in a sense, we have these three lines. I don't know the colors there, if they're visible. At the bottom is the blue, at the top there is a red line, and in the middle is the green line. The blue line shows the pace. The red line shows the heart rate. And the green line shows the HRE. And what you can see from here is a sort of more stable over time, the green line. Move on. Now, a bit of the results. So first, we started from the data set of one athlete, which is also the first author of the paper. And here we can see improvements with structured training, a peak around 2016, the plot with the label F, it's in the middle row, second one, when the runner qualified for the Boston Marathon. And then we can see a gradual decline later with reduced mileage and age. And what we wanted to convey with this plot is that this metric, in a sense, shows a more stable and long-term signal of the aerobic fitness of the athlete. And then we're asking, can we observe the same patterns? Can this metric tell us anything to distinguish, for example, between different types of runners? So when we aggregate the data and then we try to look at the 12 other runners, some patterns started to emerge. For example, here, these athletes, F and G that we call them, show consistently lower and more stable HRE, as you can eyeball the line. Whereas others like B and D, we can see some seasonal fluctuations or higher HRE values that maybe reflect less mature training. And what I want to convey here is that this metric, the HRE, can differentiate between different fitness levels. So we can see there's another way, instead of having these other two metrics, heart rate or pace, we can use this metric to distinguish between well-fitted or poor-fitted runners. And the third question that we're asking was like whether what's going on in marathons, which may require a different type of training. And here's the data that we plotted from the Larnaca International Marathon in 2017-18. And again, here we can distinguish between the two, poorly fitted and well-fitted. So in the poorly fitted case, the heart rate, the HRE decreases after the 30 kilometers, whereas in the well-fitted, it maintains a more stable, low, in a sense, HRE throughout the finishing line. And this gives a more interpretable way, in a sense, of what performance means for runners. Now, what does it mean for us? I want to give you, again, three ideas. The first one is that most of these technologies that we designed to help users, especially if they go reach the market, they prioritize we need to be prioritizing transparency instead of having these black box scores that might mean nothing in the end for the users, like what is the process of how we calculate these metrics and what they actually mean. So the idea here is that if users can't see how a metric is calculated, how can they trust it or how can they learn from it? The second idea is to rethink the long-term reflection. Most of these apps, even myself, I'm using the Apple Watch, and some of these apps already give you distance or pace over time, but they rarely show you how efficient you are as a runner. They just give you metrics, but not how efficient you are. So we argue that we need tools to help people reflect not just how far or how fast they went, but on the quality of their progress. And finally, instead of prescribing, let's say, uh, training plans, you should take these steps a day, or you should do this kind of training. I think this kind of system should empower users, and the goal here is to give more interpretable feedback that supports agency so that runners can make more informed choices rather than becoming dependent on these metrics and these very technologies that we as computer scientists develop. So what we did in this paper, we wanted to revisit this simple idea of heart rate efficiency and to show that even a simple and transparent metric can help us understand the aerobic fitness of runners. And but broadly for the HCI community is a kind of reminder that sometimes the most empowering design is not just adding more complexity, but making the data more explainable and more meaningful. Thank you.
Special thanks, Marius, for keeping it shorter than it should be. Let's have two questions, I will say, because it's lunchtime. So let's give.
Okay, thank you, Marius, for the work you did. Now, one question. As a runner myself, okay, I do, and this is from running actually activity.
Did you use any of these apps that I showed?
Sorry?
No, there is
Okay.
no causation.
Okay. I understand all this research about fatigue and the fitness level, okay, from heart rates and all the metrics. This is one thing, but I was wondering whether you're thinking it perhaps in the future, because fatigue and the matter of how fast you run, whether it is road or mountain, etc., at least 50 or 60% also depends on what you eat during the run and what you drink. So fatigue, if you don't drink enough water during, for example, a marathon, you will get more fatigue. So this is one level of metric that you show the effect, but the source can be the training level, but also what you actually did drink at the moment of the running episode. So this is to be honest, I would think that we would have a more multimodal with other sensors of hydration, etc., so that you can have more accurate results.
100%. I think this the way to capture the real progress or efficiency, if you like, depends on a variety of factors. As you rightly mentioned, it could be part of the diet or the terrain, the caffeine, or any other factor that we can think of. But when we started doing this work, one thing that was sort of challenging was like to gather data. Without having this data plus all these other data that you rightly mentioned, nobody could do such analysis. So the main purpose and the goal, what we're trying here is just that there is we want to convey that there are alternative metrics that are simpler. We can use this in the availability of course of data, augment these data sets. So this could be used as an initial data set. If you as runners, if you have any other communities that we can collect data, I would love to discuss that offline, of course, or you can contribute your data and we can build on top of this to see if there are any other longer term effects. Of course, there is a bit of bias here. We just only tested runners running in Cyprus, so we don't know what happens in other areas or but yeah, short answer, yes, it depends on the data, and then you can, if you have the data, you can do this kind of analysis.
Okay, and one last question. I see one hand from Athena.
Hello again. Thank you very much for your presentation. My question is about the sampling, the runners themselves. You showed us the numbers, but I know from experience that the gender, their demographics in general are a crucial role. We saw so many beautiful graphs, but I didn't see separating, gender discrimination, but you know what I mean, differentiation on the graphs, because there are different results depending on the age, the health, the overall health and well-being of a runner, and also their physiology in general. So which challenges did you face during your research, and how did you separate the runners themselves to achieve have results?
Honest answer, many. When we started the project, we only had the data set from one individual, and then we were like, where are we going to get data? Age, anonymity, all the ethical problems, get consent. So even we as a community, to do this kind of analysis, we need data. So we could see it as an invitation to keep these kind of databases as a live document to pour data in. So I agree with you. We didn't test for age, or if I'm right in the paper, you can read the paper. We do have the demographics of all the runners, but with this sort of small sample of individuals, we should not be able to reach any meaningful conclusion. It's more just to show descriptively what you can do with such a metric and raise awareness, if you like, that there is alternatives that are more explainable and more transparent to the runners.
No, sorry. As a follow-up question about the food and fatigue and everything, it's part of a journaling. And as I'm running myself, I totally understand. I opened my app during your presentation. It's like, what data do I have already? And I wanted to question you something like, as a runner, I take medication during my period, so sometimes I have to journal on my stamp. So maybe just brainstorming here that I would like to input that, because medication does impact my performance.
That sounds like a great point for collaboration.
Thank you very much.
Great.
Thank you very much, Marius, and all the questions.